Hello, my student ID is 105028030. I'll be talking about the domain name system, DNS. DNS is a name to address resolution protocol that maintains a list of computer names and their IP addresses because it's challenging for users to remember IP addresses. DNS therefore enables a user to communicate with the computer using its name. For example, www.google.com instead of memorizing its IP address 8.8.8.8. Transport layer protocol used by DNS. DNS uses the user datagram protocol, UDP, which uses port 53. Since DNS messages contain a single packet of data, thus don't require reliability. UDP provides an end-to-end datagram connectionless service, and it's suitable for applications involving a simple query and response to save time lost in establishing and terminating a virtual circuit connection. DNS hierarchical tree structure. DNS system has a hierarchical tree structure comprising the following domain levels. We have the root level, the top level, second level, subdomain level, and host level. The fully qualified domain level of a network resource. For example, www.google.com comes from assembling all the names of a branch and separating them by periods. So the top level domains comprise commercial companies, nonprofit organizations, educational institutions, government, or country of origin, which is represented by a two-letter country code. So in our case, .com will be the commercial company, .org will represent the nonprofit organization, .edu the educational institution, and .gov the government. Then we have the second level domains, which comprise the names of companies, organizations, and institutions. And in our case, we'll have the .com. An example of a commercial company will be Google, Microsoft, and an example of educational institution will be ECU and ANU. Then we have the subdomain level, which is optional and may comprise several names separated by a period, including departments or branches of a company, organization, or institution. In our case, we give an example of the accounts department under ECU. Then the host level, which comprises the individual computers providing the network services, which is the www. So, for example, the www.google.com comprises of the host level, the second level, and the top level domains. DNS client. It communicates with the DNS server to translate domain names to IP addresses. An operating system must be configured to use DNS, and the DNS client is configured in the Services Control Panel in Windows systems. The first DNS server configured is the most preferred, while the second one is an alternative. The DNS client keeps a local cache containing results of current DNS lookups, and this speeds up communication by removing the need to communicate with the DNS server for current lookups. In translating a computer name to an IP address, the DNS client maps a domain name to a computer name, since DNS servers require a domain name as well as a computer name. How a DNS query works. A user who wishes to connect to browse www.google.com will enter this website's domain name in the browser address field. The web browser will contact the DNS client service on the user's computer. If the DNS client doesn't have the response to this query in its cache, it will contact the local DNS server, which similarly maintains a cache containing results of current DNS queries from another DNS server. And if the same doesn't have the query in its cache, it consults a routes hints file comprising a list of IP addresses of internet root servers. And these root servers keep records for top-level domain servers. The TLD servers maintain records for second-level domain servers that keep different levels of domain information. So this is just a pictorial representation of how a DNS query works. So the user will enter the www.google.com in the browser address field. If the DNS client doesn't have the response, it will the web browser, if the DNS client doesn't have the response, it will query the local server. And if the local server doesn't have the response in its cache, it will query the root server. And the root server will respond by telling the local server to check certain top level domain server, and it will query the .com TLD server, as Google is a commercial company. And if the .com TLD server doesn't have the response to the query, it will respond to the local server to try the google.com DNS server, and the local server will query the google.com DNS server. And if the local.com DNS server has the IP address for Google, it will respond to the local server with the IP address, which is 8.8.8.8, and the local server will respond to the DNS client with the IP address, and the DNS client will respond to the web browser. In this case, it will enable the user to connect to this web page. I'm just going to demonstrate this on Wireshark. We're just going to minimize this and go to command prompt. Just first type ipconfig to all so that we can view the DNS IP addresses of the DNS servers and my IP address. Here we have my IP address is 10.65.40.75, which is the one which is preferred. And we have the DNS servers IP addresses, which is 10.240.180.4 and 10.241.180.6. And the first one is the one which is preferred. Then we'll do ipconfig display DNS so that you can see the DNS the DNS what the DNS my DNS client cache contains, the current DNS queries and their IP addresses. And we're just going to flash these so that we can have a fresh capture on Wireshark, and it's successful. So we're just going to minimize this and open Wireshark. I'm using wireless, so we're just going to click on Wi-Fi. Wait for it to start capturing traffic. That's it. We're just going to minimize that and go to our browser and just type a website that we want to visit, for example www.reddit.com. So yeah, the page is loaded and we can see it's secure because it has the green padlock. If we click on it, it shows that the connection is indeed secure. So we're just going to close that, go back to our Wireshark, stop capture, and then filter, and the filter field just filter the DNS, and we're just going to look for our specific query. Which is here, and we can see that the source IP is 10.65.40.75. The destination is 10.240.180.4, which is the destination IP for the DNS. It's a standard query on our website. You can see the website we viewed, and we're just going to go here to view the contents, and you can see it uses the user datagram protocol. As we saw, the source port is 62.312, the destination port is 53, which is the standard UDP port. It shows the length, the checksum. You can just go here to the domain name system query, and you can see the transaction ID, and it was a standard query. The question asked was 1. Answer was given, and the query was www.reddit.com, and the response time was 4:21 seconds. And this shows that we are able to view how a DNS query actually occurs in Wireshark. That's the end of my presentation. Thank you.